All right, so the question here is about carbenes. Carbenes are cool molecules. They're really interesting species. They're very, very unstable. So when it says fleeting existence, it means that you can make a carbene, but you can't really put it in a bottle. You can't even really observe it for very long. It'll go and do something, react with something, or decompose very quickly. But we do know that they exist because we can uh, observe them with spectroscopy and other techniques. And here's an example. The simplest carbene is CH2. It's divalent, so uh, that means it has two things attached. And a lone pair here, or two other electrons, and two unshared electrons. So these are what make carbenes interesting. So this is called methylene, and the question is, the two unshared electrons can either be paired in a single orbital or unpaired in different orbitals. So predict the type of hybridization you expect carbon to adopt in singlet, that means spin paired methylene, or triplet, spin unpaired methylene. Let's draw a picture of each and identify the valence orbitals on carbon. Okay, so if we look at what happens if these two electrons are in a spin paired state, that means they're in the same orbital. So that would put them, let's just say they're in an orbital like this where they're paired up. So we could also draw it like this, where their spins are paired. Because they're in the same orbital, their spins have to be paired. And if this is one orbital that contains this lone pair, it's just like the lone pair in the carbanion that we talked about in the last problem. So you would have this lone pair in this negatively charged carbanion in a single orbital, two electrons spin paired in a single orbital, just like here. And since there are essentially the steric number, that puts the steric number of this carbon at 3, because the lone pairs count when you're counting steric numbers. So this is, I'll just put this in a different color, 1, 2, 3. If there are 3 things attached to this carbon, that means it has a steric number of 3. That means it's sp2 hybridized. And if it's sp2 hybridized, that means that it has 3 sp2 orbitals. So it has this sp2 orbital with the lone pair in it. There's another one and another one. And then the hydrogens are hanging out here and here, overlapping with their 1s orbitals, are overlapping with the other 2 sp3 orbitals. And so that's where we get these sigma bonds there. This is an sorry, did I say sp3? I meant sp2. And this sp2 orbital here is just hanging out with a pair of spin paired electrons. And that leaves us with a p orbital here that's empty. So this is a p orbital in methylene, carbene. That is empty. So this is one form. This is the spin paired, the singlet form. What about the triplet form? Well, that means that if these spins are not paired, they have to be in different orbitals, right? So let's draw this in a different color here. So if we have this hydrogen and this hydrogen, so it's still the same number of atoms and the same molecular formula, CH2, but what's going on with the electrons? If they're unpaired, they, by the Pauli exclusion principle, they are in different orbitals. And so we'll put one in one orbital and another in another orbital. And those have the same spin. If they're in different orbitals, that gives them sort of their own status, individual status when you're talking about steric number. So let's count the steric number here. This one, this one, this one, this one. Now you have 4 things attached. So you might think, well, this is crazy. Why are you counting a single unpaired electron when you're counting the steric number? Well, it's in an orbital, and so you count orbitals just like you count atoms that are attached when you're looking at steric number. And since these unpaired electrons are in different orbitals, each one of them is counted differently, and that means that you have an sp3 hybridized methylene here. So if we want to draw, again, if you're thinking about the geometry, these two orbitals, these two sp3 orbitals with the unpaired electrons, let's say they're in the plane of the board. That means that this hydrogen and that hydrogen are coming out and going back into the board so that we have a tetrahedral geometry. So this is tetrahedral. Whereas this is trigonal planar. The one on the left, the singlet spin paired carbene, is trigonal planar. So that's the 2 forms of carbene.